Hi, this is Alix Paultre with Open Systems Media and Embedded Computing Design, and I'm here with a good friend of mine, Jim Witham from GaN Systems. Well, hey Jim, it's always nice to see you.
Good to see you, Alex.
Well, we're at the GaN Systems booth. Wide-bandgap, has been a promise for so long, and it kind of arrived last year, but now we're actually seeing it in real products, we're seeing it in volumes. What can you tell us about that?
Absolutely. We're seeing volumes in three marketplaces. One is solar ESS systems, another is data center, and we're standing here in front of our consumer exhibit. So why don't we show you some of the things that are happening there?
Yeah, cool. What do we got?
So there's adapters right here, so wired adapters. We're talking about things for cell phones and computers and gaming computers and the like. We have wireless charging on the far side, and in the middle, a couple of consumer applications that are kind of cool.
Really nice. Like, what is this? Or what is this supposed to be?
This is a medical device from one of our customers. It's an anti-wrinkle device, and it uses very high-frequency signals generated by GaN transistors to take away wrinkles. I think it could be a big seller here at APEC.
Well, there are some of us a little long in the tooth, my friend.
No comment.
But that is an actual, there you go. So it's a health and beauty device. Obviously, it's a cutting edge area. You have to have really cool equipment to get, because it's also a bit of marketing in that space. It has to be nice equipment, it has to work, and the form factor doesn't hurt.
Yeah. Absolutely. And, a lot of people in the power industry are focused in on, what's happening in automotive, what's happening in data center, what's happening in phone chargers. And those are interesting, right? Because they're big volume applications and they make revenue and they make success stories out of companies. But, those are good, but I like a lot of these little companies in these little applications that couldn't have been done without GaN transistors. And it's fun to see them come to marketplace also.
Very cool. Now, Jim, is there another, like you were mentioning that there are some application spaces that couldn't have been addressed before. Are there some app spaces you're seeing addressed now that weren't addressed before with GaN?
So, yeah, let's go over the wireless charging, because, wired chargers, these are stuff that we carry around with us all the time. They're just smaller when you use GaN. But in wireless charging, we're enabling some applications that just couldn't be done. This is an interesting one. It's an electric scooter. We had to do it on an iPad because the scooter and the pad were too big to roll in for our small booth here. But here's a way that people don't have to plug in a cord every time they want to charge their electric scooter. They can just drive it up over a pad, in their garage area, wherever they're parking, wherever their apartment is, and go have charging. This one here, we're going through a wall. So we're talking 2x4s and press board, 8 inches or 200 millimeters of throw distance wireless power transfer. Who would care about this? Security cameras. You want to put a security camera on the outside of your building or your home, and you don't have any power out there. You've got power on the inside. You can now do your data and power through the wall by doing high power wireless power transfer with GaN transistors. So 2 examples of things that couldn't have been done if you didn't have GaN.
Well, that whole aspect of having the external cameras and the wireless power, that could also apply to low power lighting, that could apply to any kind of external electronics.
There's when we first did it, it was about security cameras, right? And then there's a whole host of applications, just like you're talking about, that want to have this same capability. And then, the real big one here is 5G modems, right? Because 5G data can't go through the wall at that high frequency, and so you have to be able to receive the data on the outside, change frequency, and get it in the inside of the home or the office to be able to get that high bandwidth. And so there's lots of short-term applications with this, and also a big fish in the pond for future application.
Really nice, Jim. Now, hey, any last words for our audience? I mean, we always talk, but sometimes I forget to ask you things.
Well, there's a lot of customer applications here that are using our GaN transistors, so come by and see our booth. And if you aren't here at APEC, then come visit our website, www.gansystems.com, and you can see a whole plethora of information about applications where people are using GaN.
Very cool, Jim. Thanks you so much again to talk again.
Sure, it was my pleasure.
Mine too.